Today we're going to look at graphing quadratic functions, and quadratic functions typically appear in one of two forms. We're going to start today with the vertex form and then move to the standard form. The vertex form is f of x equals a times x minus 2 quantity squared plus k. Now it's important to know what a, h, and k really represent. The vertex, in other words, the highest point or the lowest point on a parabola, is the point h comma k. And this little number out front, a, tells us the parabola opens up if a is positive or down if a is negative. And we know a parabola forms like a U shape and it's symmetrical. And there's something called the axis of symmetry, which is a vertical line which passes through the vertex. And the formula for that axis of symmetry is x is equal to h. Now when we start graphing quadratic functions, there's really three things we want to find. Three points or sets of points that we want to calculate. The first is the vertex. The second is the y-intercept, and the third are the x-intercepts. There could be 2, there could be 1, or there could be no x-intercepts. Let's see how this works. We're given an example. It says graph the following. f of x is negative 2 times the quantity x minus 3 squared minus 5. Well, we should already realize that this negative 2 out front tells us the parabola faces downward. And we should also realize that according to our formula, x minus h is 3, plus k is negative 5, so the point 3 comma negative 5 is actually our vertex. So we already have one point 3 comma negative 5, and I plotted it down here. That's that top point. The next part says find the y-intercept. Well, by definition, your y-intercept is where x equals 0. This always occurs. So I simply plug in 0 for x into my equation. I get negative 2 times 0 minus 3 squared minus 5, which is negative 2 times 9 minus 5, which equals negative 18 minus 5, which is negative 23. So our point is 0, negative 23 is the y-intercept. So I've plotted my 2 points. And I know this is the vertex, and it goes downward, so I'm on the right track. Your next step is to go with the x-intercepts. And by definition, your x-intercepts are where your f of x or your y is equal to 0. So I set my left side of my equation equal to 0. And then what I'm going to do is I'm going to expand the right side of my equation. I'm going to take this x minus 3 and square it, and that gives you x squared minus 6x plus 9. I'm going to distribute the negative 2 in. Then I'm going to combine like terms. I get 0 is negative x squared plus 12x minus 23. This is a quadratic equation. We've already practiced solving these. We have several different ways of solving them. The two most common ways I like are factoring and the quadratic formula. I look at this real quick and don't see how I can factor it. So I'm going to plug into the quadratic formula. My a is negative 2, my b is 12, and my c is negative 23. So for my formula, x is negative b plus or minus b squared minus 4ac over 2a becomes negative 12 plus or minus the quantity 12 squared minus 4 times negative 2 times negative 23 all over 2 times negative 2. Now when I go to simplify this, I'm going to get 144 minus 184 underneath my radical. And that reduces to the square root of negative 40. I cannot graph the square root of a negative number. And hence that tells me, if you remember from your last chapter, that's your discriminant. And your discriminant is less than 0. That means I have imaginary solutions, so there are no x-intercepts. So basically all I have is 2 points to graph my quadratic with. And we should be able to do that. We have the vertex, we have the y-intercept, and I know it's symmetrical. So I should be able to get a good sketch of my actual parabola. Now, along with the vertex form is something called the standard form of parabola, which is f of x equals ax squared plus bx plus c. You should recognize the ax squared plus bx plus c. That's what we talked about already when we talked about quadratic equations. Now this one's a little bit different. Our axis of symmetry, we actually have to calculate it. It's not given to us right away. It's actually x equals negative b over 2a. Now if you remember what I said earlier, the axis of symmetry passes through the vertex. So to get the vertex, my x value is the negative b over 2a, and the y value, I have to plug in the negative b over 2a into the function to get the y value. Once again, this a out front tells me if the parabola opens up if a is greater than 0, and opens down if a is less than 0. Let's look at an example of this. I'm given the function f of x equals 2x squared plus 20x plus 8. I recognize this automatically as a quadratic because I have a square term, a linear term, and a constant term. First thing I want to do is get the vertex, just like my previous problem. Again, the vertex isn't given to me, I have to calculate it. I have x as negative b over 2a. And when I plug in 20 for my b and 2 for my a, I get negative 20 over 2 times 2, which is negative 5. That is my axis of symmetry. It's not my vertex. My vertex is a point, so I need to plug that negative 5 into my original function. I get f of negative 5 is 2 times negative 5 squared plus 20 times negative 5 plus 48. And when you simplify that, you wind up with negative 2. So your vertex has an x value of negative 5 and a y value of negative 2. Hence, we have our first point. And we should know, at the point negative 5, negative 2, the parabola faces upwards. This vertex is your lowest point on your parabola. Now, step 2 is the y-intercept. For your y-intercept, you plug 0 in for x. And when we plug 0 in for x, we get 0, 48. So here are my first 2 points. I have the point negative 5, negative 2, and 0, 48. Here are my first 2 points on my graph. My next step is to get my x-intercepts. Again, the 2 ways I like doing that are factoring or graphing. I notice right away that all my terms I can pull out a 2 from all these terms. I can basically divide everything by 2 if you want to think of it that way, and just get rid of the 2 because dividing 0 by 2 keeps this 0. And then my right-hand side becomes x squared plus 10x plus 24. This quickly factors to x plus 4 times x plus 6. And if I solve each one of these linear equations, I get negative 4 and negative 6. Now don't make the mistake thinking that negative 4 and negative 6 is a point on your graph. That isn't the way it works. These are both x values. I need y values to go with these. Well, to get my x-intercept, I plug in 0 for y. So each one of these points are negative 4, 0 for y, and negative 6, 0 for y. If I plot my other 2 points along with my vertex and my y-intercept, I get this nice little shape. And then what's good about this is I can simply connect my dots now, and I get this wonderful looking parabola. I hope this helps you this week. Let me know if you have any questions.